Hey everybody, this is Mr. Ainsworth, and we're going to get into our quiz corrections on section 6.5 here, graph and inequalities. So it covers quite a bit. So get your red pens, get your graph paper out on any one that you missed. Go ahead and detail it out on graph paper and make sure you write down everything that I detail out. All right, make sure you do it properly because I'll be looking at your corrections. And if they are not detailed out properly, then I will not allow you to retest. Okay? So, quizzes are a learning experience. They're kind of like scrimmages before a game. I don't mind you retaking a quiz after your corrections, but you got to do it right, and then you got to practice. Okay, and that's the deal. So, if you made mistakes, okay, that's one thing, but you need to fix them and then practice the right way. All right, so let's take a look at the first problem here. We want to test 4 comma 5. All right, x is 4, y is negative 5 in each equation, and determine whether it is a solution or not. So you need to determine whether it's a solution or not. Okay, so what we do is we substitute negative in for 5, negative 5 in for y. We've got negative 5, is that less than or equal to 3 times x, which is 4, just take a look up there, plus 2. All right, we've got to simplify. So negative 5 is that less than or equal to 12 plus 2, which is 14. So negative 5 is that less than or equal to 14. Well, if you look at a number line, okay, and let's say here's a number line here. Here's 0, way over here is 14. Over here is negative 5. All right, it's to the left of 14. It's smaller, so it's true. So because it's true, that means, all right, that 4 comma negative 5, 4 comma negative 5 is a solution to the inequality. If it was false, I would say, no, it's not a solution, all right, but it's true. So after you substitute the point in, if you end up with a true inequality, well, then it's a solution. If not, it means it's not a solution. That's all you do. So on the next one here is negative 3 times x plus 2 times y. Is that greater than 2? Well, like I said before, x is 4, right? So you substitute in 4. Y is negative 5 right here, so you substitute negative 5. So right here and right here. Okay, you substitute your values in. Negative 3 times 4 is negative 12. Plus negative 10, is that greater than 2? Well, negative plus an 8 is a bigger negative, so is negative 22 greater than 2? And a negative cannot be greater than a positive, so this is false. And that tells me that my test point for a negative 5 is not, all right, a solution. That's what it means. It doesn't satisfy the inequality. Okay? Now, in equalities here, this is an equality, not an inequality, do the same thing. So is y, which is negative 5, is that equal to 3 times x minus 17? So I got to substitute x, 4 in for x. Look right here, 4 is equal, x is equal to 4. And I got to work it out. So is negative 5 equal to 12 minus 17? And I say yes, because 12 minus 17 is negative 5. So is negative 5 equal to negative 5? And the answer is yes, of course it is. So that tells me that my test point for a negative 5 is a solution. That's important when you deal with inequalities because when you graph them, you got to determine the solution region. Where are they? So we're going to test some points. So this skill right here is important, okay? So this next one here, we're going to graph this inequality. And the first thing I want to do is I want to isolate y, okay? I want to get y either less than or greater than mx plus b in slope-intercept form right here, okay? So the first thing we do is we add the opposite of 5x. So that's negative 5x. And let me see, opposites always cancel to 0. 0 plus 2y is 2y. That's greater than negative 5x plus 6. Now, 2y means 2 times y, so you want to do the inverse. The inverse of multiplying is dividing. So you divide everything by 2. Whenever you divide an inequality by a number, you divide all terms by that number. 2 divided by 2 is 1, and 1 times y is y. That's greater than negative 5 divided by 2, or negative 5 halves x, plus 3. 6 divided by 2 is usually 3, especially today. All right, and so when you compare this, this is m and this is b. This is your slope, and there's your y-intercept. Negative 5 halves, which means down 5, right 2, at the y-intercept of 3, or 0, comma 3. This is your y-intercept. So you start graphing at 3. There's 3 on there. Between 2 and 4 is obviously 3. And then from there, you got to go down 5 right too. So 1, 2, 3, 4, 5, 1, 2 to the right. 1, 2, 3, 4, 5, 2 to the right. So you just keep on repeating that and you draw your line. The question is it solid or dotted? So let's take a look at this. Let's go right here. Test the y-intercept to determine whether those solutions lie on the boundary line. What I just drew is the boundary line. Now right here, this is 0, 3. That's my y-intercept. Is that a solution? Should solutions be on the boundary line? So let's test it. And you always test it in the inequality here. Okay, so let's test it in 5x plus 2y greater than 6. Always test it in the original. So I want to test my y-intercept. So it's 5 times 0 plus 2 times 3. Is that greater than 6? Well, let me see. 0 plus 6 is 6. And is 6 greater than 6? And I say false. So what does that mean? It means that our test point 0, 3, we're testing 0, 3 here. That's what we just did. 0, 3 is not a solution. What does that mean? It means dotted boundary line. That's what it means. Dotted boundary line. The boundary line's dotted. So get out your eraser. And, the solutions don't lie on the line because I just tested one point on the line and it doesn't work, right? So what you do is you make it dotted. Dotted boundary line means the solutions do not lie on the line. Solutions do not or don't lie on the boundary line. Now, if you're doing corrections here and you didn't write that down, I want you to, all right? This proves to me that you actually listened to my video and you actually wrote down the important points. The dotted boundary line, okay, that means that solutions don't lie on the line. So the question is, do they lie above or below? And that's where this comes in. You got to test the origin. Not that you have to test the origin. You can test any point you want. However, this is the easiest point to pick, right? So if it is a solution, we'll shade below because the origin's below the boundary line. If it's not a solution, they're on the other side and we'll shade above. All right, that's all you do. So let me see, 5 times x plus 2 times y is greater than 6. So x is 0, y is 0. So you substitute 0 for both of them. And ask yourself the simple question. Okay, that's 0, that's 0. 0 plus 0 is 0. So is 0 greater than 6? And the answer is false. So what does that tell you? That tells me that 0, 0 is not a solution. Now think about it. If this is not a solution, then they can't lie below. They got to lie on the other side. And that's why we shade above. So get out your highlighter. Ooh, let me fix that. You got to be careful here. Solutions only lie above this boundary line or on the opposite side of 0, 0, right? This is what's called the solution region. All these points, there's an infinite number of them. They all lie on the other side of 0, 0 because this is not a solution. That's what the test points tell you. If I test a point on the boundary line, it's false, it's not a solution, then solutions don't exist on there, and they obviously they don't, and that's why we make it dotted. That's what dotted means. And then we test a point. It can be any point. I just test 0, 0 just because it's the easiest point to pick on the whole coordinate plane. And if it's not a solution, that means the solutions are on the other side. So shade above, or shade on the opposite side of 0, 0. That's all you do every single time. You test a y-intercept, you test 0, 0, and you can figure this stuff out without knowing any fancy tricks or anything. All right, so let's do it again. Let's isolate y again. Here we go. So let's add the opposite, so which is a negative 3x. And you get 0 here. 0 minus 4y is negative 4y is greater than or equal to negative 3x plus 12. Notice that I do it step by step here. I always add the opposite of x first. If you listen to all my lessons, I say that in every single lesson. It's not that hard. You just do it every single time. And then whatever you see for the coefficient of y, here it's negative 4 times y, you divide all terms by the coefficient of y. And so what do you get? You get y is less than or equal to. Notice the switch from less than or equal to greater than or equal to, because you got to switch the inequality when you divide by negative. Switch inequality when dividing by a negative. That also applies to multiplying 2, by the way. So circle that or highlight it, because that's an important point right there. People forgot about that on the test. A negative divided by a negative is a positive, so you get 3/4 x minus 3. You got to simplify. So my slope is 3/4, up 3, right 4, from negative 3. There's your y-intercept. So what you want to do is you want to solve for, or you want to plot first, this first, as I say every single time. You plotted 0, negative 3, which is down here 3 units below the origin. And then you got to go up 3, right 4. So put your pencil at negative 3, go up 1, 2, 3, right 4, 1, 2, 3, 4. And get your straight edge out. Draw your line. Question is, do points lie on the boundary line? This is your boundary line right here. So let's test that. Let's take your y-intercept right here. Again, test the y-intercept at 0, negative 3. And let's test it in the original inequality. 3x minus 4y is greater than or equal to 12. You always test there. And let's see if it's a solution. So is 3 times 0 minus 4 times negative 3, is that greater than or equal to 12? Well, that's 0. And this is 12, because a negative times a negative is a positive. And so the question is 0 plus 12 greater than or equal to 12? And the answer is true. Okay, 12 is greater than or equal to 12. That tells me that 0, negative 3 is a solution. What does that mean? That tells me that the boundary line is solid. Okay, notice my arrows here. That means implies. Okay, anytime I draw an arrow, that means implies. So true statement, when the inequality is true after you substitute a point in, that tells me that the point's a solution, and that tells me that the boundary line is solid. So I'm not going to make it dotted, because the solutions are on the boundary line. Solutions are on the boundary line. Okay, so the question is, are they above and or below? So you test 0, 0. X is 0 and y is 0. So let me rewrite the inequality over here. So we got 3x minus 4y is greater than or equal to 12. So the question is 3 times 0 minus 4 times 0 greater than or equal to 12? Well, what's 0 minus 0? Well, it better be 0, right? So the question is 0 greater than or equal to 12? And remember, here's your test point, right? 0, 0. And that's false. So what does that tell me? It tells me that 0, 0 is not a solution. Okay, so if it's not a solution here, not a solution, that tells me that they got to be on the other side. They got to be below. And I already expected that because of the less than or equal to. So we shade below. So you don't have to know any rules. You can just, hey, you can just test a point like 0, 0, which is the easiest thing on the planet, and then figure it out without remembering any fancy rules. Okay, that's why I have you test the 2 points, the y-intercept and the 0, 0. All right, and same is applied to all of these. Okay, and then all of these, guess what? Well, at least the first 4 in slope-intercept form. So when you take a look at this, you can take a look at the slope and the y-intercept. Here, the slope is negative 6/5, which is down 6 right 5, from the y-intercept of 0, negative 1. See, this is M and this is B, right? So you plot it at negative 1, and then I go down 6 right 5. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. Right about here. Or reverse it. 6 divided by -5 is the same thing. So you go up 6, left 5. You reverse it. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. Right here. And so you get out your straight edge. All right, draw your line. All right, now this is, you test a point like 0, -1. So you substitute that in. So let me see, I'll use the margin here. So you put -1s, 0, -1. Here's your y-intercept, right? So x is 0, y is -1. I mean, I know it's going to be solid just by looking at the inequality right here. I know it's going to be solid and above, like right up through here. However, those are things that I know from experience, right? But if you want to substitute it in, the question is -1 greater than or equal to -6 times 0 minus 1? And if you simplify this, you get this right here, -1 greater than or equal to -1, which is true, right? So it's solid boundary line. 0, 0 is right here. Is it a solution? If you put a 0 here and a 0 here, what do you get? Well, you get 0 greater than or equal to -6 times 0 minus 1. So is 0 greater than or equal to -1? And the answer is yes, of course. 0 is greater than any negative number, so this is true too. All right? So this is a solution. So this is your solution region right here. So let's shade it in some more. Okay? But I already know, from experience here, guys, that greater than or equal to is going to be solid and above. I'll write that down. Solid and above, just from experience, because I've done 1,000 of these. And if you did your homework correctly all the time, you'd figure that out too. All right, because it's not hard. Either, if it's greater than or greater than or equal to, it's above. If it's less than or less than or equal to, it's below. It's that simple in slope-intercept form. Now, on this one here, on number 2, all right, your boundary line is y equals -5. And I taught you guys, I said, hey, if you don't remember what's vertical, horizontal, just pick 2 coordinates where y is -5. Like 2, -5, and how about 0, -5? Just pick any 2 points. Okay, because 2 points determine a line. So 2, -5 is down here. 0, -5 is right here. And guess what? Here's your boundary line. All right? But you got to make it dotted because y cannot be equal to -5 because it's strictly greater than. So get out your eraser, make it dotted, and just think about it. On the y-axis, let me change to red here. This is the y-axis right here. This is -5, right? And this is -4, -3, -2, -1, 0, 1, 2, and 3. All of these right here and up are greater than -5. Greater than or equal to. So it should be open right here, actually. And so all the y values above this line are greater than -5. All of them. So any point in this region is a solution. Any of them have y coordinates greater than -5. Just plot one and pick. You'll see what I'm talking about. Okay, on this one, slopes 2. Here's the slope. Here's the y-intercept. So slopes 2, which is 2 over 1. That means up 2, right 1, from b equals 4. So you start here at 4, and you go up 2, right 1. Or reverse it. Down 2, left 1, down 2, left 1, down 2, left 1, down 2, left 1. Now it's greater than or equal to. See that right here? So that tells me it's going to be solid and above. I can already tell. So, but if you don't know that, then you test a point, right? So you test the origin, let's say. So let's test it. Is 0 greater than or equal to 2 times 0 plus 4? So is 0 greater than or equal to 4? And that's going to be false. So 0, 0 is not a solution. So it's not. So it's got to be up here. That's why I said above, right? I can always tell. So you can test a point and verify everything I'm saying. You can learn the quick ways to graph, and determine the solution regions, which I hope you do, because if you're going to get in any higher mathematics, you have to know these things from experience, and you just go with it. But you can also test a point as well. All right, next one. Boundary line is x equals 2. So if you plot 2 points where x is 2, like 2 comma 5 and 2 comma negative 2, right 2 up 5, right 2 down 2, right here, you're going to notice that it's vertical. All right, so here's your boundary line. So where are the x coordinates less than or equal to 2? So here's 2, and here's 1, and here's 0. All these numbers here to the left of 2 are less than or equal to 2. All of them. So you got to shade left. Okay? And that's all there is to it. Now, if I'm going a little bit too fast, don't worry about it. It's a video, right? Go ahead and rewind it. Listen to it again and again until it makes sense to you, and go at your own pace. All right, on this one here, x minus 5y is greater than negative 15. Let's add the opposite first. Bring this term down here. Negative 5y is greater than negative x minus 15. Here I want to divide everything by negative 5. Remember, when you divide two negatives, you get a positive, and switch the inequality. I'm talking about from greater than to less than. Make sure that you do that. All right, negative divided by negative is positive, so I get 1/5 x. Negative 15 divided by negative 5 is positive 3. So there's my slope and there's my y-intercept. So on a slope of 1/5, you got to go up 1, right 5 from 3. So right here, you got to go up 1, right 5, or down 1, left 5. Okay, and then you have to make it dotted. Now, when I look at this right here, I'm thinking dotted boundary line and below. And below. Well, I'll verify that for you. So I'm going to make it dotted. Just take your eraser out. And I'm going to shade below, but I'm going to prove it to you why it's below, because I'm going to test the origin. I'm going to test this, the easiest point, which is 0, 0. I'm going to show to you that it's a solution. So you put 0 here and a 0 here. So is 0 less or minus 5 times 0, is that greater than negative 15? So is negative, excuse me, let me redo that. So this is 0. So is 0 minus 0 greater than negative 15? Is 0 greater than negative 15? And the answer is yes. Okay, that's true. So what does that tell me? That tells me that 0, 0 is a solution. So that tells me that all of these down here are solutions. Okay? And that's all there is to it. I'm doing the same thing in every single problem. You just have to get the experience that you need. Okay, on this next one, 2x plus y greater than negative 5. If you add the opposite first, you get y greater than negative 2x minus 5 because it's negative. There's your slope, and there's your y-intercept. Now, when you have a slope of negative 2, that means negative 2 over 1, or down 2 right 1 from the y-intercept. Or it means up to left 1. You got to reverse it. So up to left 1, up to left 1, up to left 1, or down to, down to right 1, 1, 2, right 1, right here. So, you can go either way. Let's go ahead and graph the boundary line. Now I can already see, just by looking at the inequality right here, let's highlight this right here, that it's going to be dotted and above. And I'll prove it to you. Dotted and above. So I'm going to shade above. But the reason why it's above, because this solution right here, 0, 0, is a solution. Put a 0 here and here. Let's see what we get. It is 2 times 0 plus 0 greater than negative 5. And I say yes, because 0 is greater than negative 5. So this is a solution. This is the solution region. So you highlight the solution region. Okay? And that's all there is to it. You just have to get some experience and you got to correct your mistakes. You have to correct your mistakes first. All right? And practice the correct way. All right? Multiple times. What does that mean? It means multiple times. That means you have to do your homework. Go back into your notes and practice. That's what you have to do. All right. So after you correct your quiz here, if you need to listen to the video again, well, it's a video, so go ahead and do it. All right. And practice each one of these. Get some more graph paper out, state the problem down, and work it out. See if you can do it on your own. Because I can guarantee you that it's one thing watching me do it, it's one thing correcting your quiz. It's another thing being able to do all this on your own. So practice each one 5 times each. Practice each one missed 5 times each, 5 times each, and here's the key, the correct way. All right, you do that and you'll get better, okay? And you can also go into your notes, as I said on the previous video when we corrected a quiz, and practice ones we did on our notes the correct way. That's all it takes, guys. If you go home and actually do your homework correctly, practice the examples in your notes correctly, because perfect practice makes perfect, not just any practice, then you'll do much better, okay? You do this and you provide evidence that you did all this correctly, and then show me your practice as well. I'll let you retake this quiz any day of the week. All right? Give it your best. Make yourself proud, and I'll see you in my next lesson.